Good afternoon, class. Thank you. You can sit down. All right, then the first thing we'll do is to go through the last 4 questions I think we didn't complete in our last lesson on writing equations of straight lines. And then we'll look at linear models. All right, it was, I think, letter O, P, Q, and R. After this, we'll go through a few questions that some of you felt that the answers were wrong. So we'll go through that later. Okay, letter O. Is there anyone with an answer to letter O? Patrick, give us the answer to letter O.
Y equals x minus 3.
Y equals x minus 3 is correct. Letter P, Geno.
Negative x plus.
Oh, negative x plus 6. Negative x plus 4. Okay, y equals negative x. Geno has plus 6. The rest of you have 4. Okay, if we were to find the gradient, the points that are given are 4, 0, and 2, 2. All right, the gradient will be 2 minus 0 over 2 minus 4, which is 2 on negative 2, which is negative x. If we substitute the point 4, 0, we will get, the equation will then be in this form, y equals minus x plus c. If we substitute the point 4, 0, we will get 0 equals minus 4 plus c. So c will be equal to 4. You have to substitute a point, not a number from 2 different points. You can either substitute 4, 0, or you can substitute 2, 2 as well. If you substitute 2, 2, you're going to get 2 here and minus 2 there, and then you'll get c equals 4. So the equation is y equals minus x plus 4. That's for letter P. Letter Q, anyone wants to give us the answer to letter Q? Yes, Pon Relay.
Y equals a third x.
Y equals a third x. You all get y equals a third x? Okay. Letter R. Miriam, your answer to letter R, please.
Y equals negative 3/4 x plus 1 1/3.
Is it 1 1/3? Y equals minus 3 on 4x plus 1 1/3 is 4 on 3. Is it 4 on 3? Who's got a different answer? Rita?
It's 5 on 4 plus 5.
Y equals minus 3 on 4x plus 5 on 4. Any other person with a different answer? All of you have either these two. Okay, the gradient is 2 points that are clear, 3, negative 1, and 1, 2. So it will be 2 minus negative 1 over minus 1 minus 3. So I get 3 on negative 4, which is the same as negative 3 on 4. So the equation will be y equals minus 3 on 4x plus c. If I substitute the point negative 1, 2, I will get 2 equals minus 3 on 4x, which is minus 1, plus c. I get 8 equals minus 3, sorry, plus 3, and plus 4, C. Subtract 3 on both sides, I get 5 equals 4C, and C is equal to 5 on 4. So the answer is this one. Y equals minus 3 on 4x plus 5 on 4. Okay, is there any question from anyone on what we have done so far up to this point? No? Okay, so you're telling me you're all experts. Okay then. We look at, oh sorry, yeah. Thank you. Corrections, you have to tell me the number. Letter H. Okay, I'll just redraw letter H on the board. Okay, this was question letter H. The gradient, this is 5, 0, and 0, 2. There are 3 points. This one is 0, negative 1. But if I use those 2 points, I will get 0 minus 2 over 5 minus 0. Is the gradient negative 2 on 5? For letter H. Check letter H, please. This is 2, 0, 2, and this is 5, 0. Huh? And the line goes through negative 1 here. Am I looking at the wrong one? I'm looking at letter H. Oh, sorry. You are right. The line doesn't pass through here and doesn't pass through here. It passes through 5, 2. Okay. So it's going to be, this one is 1, 1, 0. 0 minus 1. So I get 2 minus negative 1 over 5 minus 0, which is 3 on 5. Okay, so the gradient is supposed to be 3 on 5. We said the gradient was 5 on, well, I said it was 5 on 3. It's supposed to be 3 on 5. So the actual equation for letter H is y equals 3 on 5x minus 1. Okay, another one? Okay, letter I was the y-intercept negative 2, and the point given is minus 3, positive 4. Okay, this is 4, and this is minus 3. Is that the one? Okay, so the gradient will be, this is 0, negative 2, minus 2, minus 4 over 0, minus negative 3. It's negative 6 on 3, which is 2. Sorry, negative 2. Am I right? Okay, so the equation for this is minus 2x minus 2. That's for letter I. Another one? M or N? M. G-H-I-J-K-L-M. Okay, that's the line for letter M. The gradient will be equal to 0 minus negative 2 over 4 minus 1. 2 on 3. Okay, the gradient is 2 on 3. Y equals 2 on 3 x plus c. So I get minus 2 equals 2 on 3 times 1 plus c, which is negative 6 equals 2 plus 3c. I get y-intercept is negative 4. Sorry, negative 2. Is that right? Okay, this is negative 8, sorry. Y-intercept is negative 8 on 3. So the equation for letter M is y equals 2 on 3x minus 8 on 3, which is the same as negative 2 and 2/3. Is that all? Letter H, I, and M. M or N? MN. Okay, 2 points. I'll just write down the points that are given on the line. 2 points that are given, minus 5, 0, and negative 3. What's the y coordinate? 6? This is letter N. Minus 3 what? Minus 2 minus 3. Okay, positive 3. M equals 3 minus 0 over negative 2 plus 5, which is 3 on 3. 1. Yeah. 3 minus 0. y2 minus y1 over x2 minus x1. You're going to have 2 negative signs here, so that's why it's plus 5. So y equals x plus c. If I put the point minus 5, 0, if I substitute, I get 0 equals minus 5 plus c. c equals 5. So the equation y equals x plus 5. Oh, what? Some of you still look as if you disagree. What's the problem? Okay, any questions now? No questions? You all happy with the answers now? Taumaku, you happy? Okay, then shall we go on? All right, linear graphs can often be drawn which fit practical situations. These graphs are called linear models of the situations which they represent. We've got an example. It's the graph of the speed s meters per second of a car t seconds after passing a checkpoint. And it's given by the equation s equals 10 plus 3t. Does that look like y equals mx plus c? Does the equation look like y equals mx plus c? So what would be the gradient of the line? Jake, what would be the gradient of the line? S equals 10 plus 3t.
3.
And that y-intercept?
10.
Good. Okay, so it looks like y equals mx plus c. It's just that it's written the other way around. The linear model for this situation is shown below. From the graph, I'll show that in a minute. From the graph, we can see that the speed of the car after 2 seconds is 16 meters per second. we can use the graph to find at different times, at different times, and also the time given the speed. Find speed at different times and the time given the speed. Whatever. Okay. Example 1, sorry, let's just go back. It says, from the graph we can see that the time of the car after 2 seconds is 16 meters per second. Can you locate it on your graph? On your graph, 16 meters per second. At t equals 2. Can you all see that? Okay, it might not be that clear on the graph. 2 seconds is here. 16 meters would be just above the black line. So 16 meters per second would be here. Your graph should be a better one. Can you locate it? It's around 16 meters per second. Okay, very clear. Now, what is the speed if t equals 5? What is the speed if t equals 5? Peter?
Um, 25 meters per second.
Okay, it should be 25 meters per second. You also note that this graph is not really, was not drawn very well. So the line should be here. On your graph, it should be here. Is it there on your, can you see it on your graph? Otherwise, you can also do what? Another way of working it out. The equation is S equals 10 plus 3t. What's another way of working out the speed when t equals 5? Boromir?
Substitute.
Substitute what?
T for 5.
Okay, t equals 5 to the equation and you evaluate for S. So 3 times 5 is 15. 15 plus 10 will be 25. Good. After how many seconds would the speed be? 31 meters per second. Please use your graph on your worksheet. Siegfried? Is it exactly 7 seconds?
Yes.
Okay. Solomon, how would you find that on the graph? Sorry, from the equation. How would you find 7 seconds from the equation? We help. Oh, okay, go ahead. Substitute.
This S for the speed. 31 meters per second.
Substitute S for the speed or the speed for S. Okay. You substitute 31 meters per second for S. You get 10 plus 3t. Then subtract 10, you get 21 equals 3t. And t equals 7. Okay, the graph that I've got on the screen is not really it's not really drawn correctly. Something went wrong. Okay, but it's supposed to be 7. The line is, if it's to follow the equation S equals 10 plus 3t, then that's 31. The graph should be actually here. The line should be somewhere up here for 7 seconds. So it's 7 seconds. Okay, now you are going to do number 2. Sorry, number 1 on your exercise. The formula to convert a speed in kilometers per hour to meters per second is given by m equals 5k over 18. The graph of the equation is shown below. Okay, you have to answer the questions that follow according to the graph that you've got on your worksheet. It should be the same as the one on the screen. Finished? We finish now? Okay, we have to answer the questions. You can answer them according to the graph or according to the equation. They should agree. All right, if k is equal to 60, find the value for m. Megan?
16.67 meters per second.
Okay, 16.67 meters per second. Because from the graph, because I don't have the small grids between the big squares, you can even have, if closest to 17, it will be accepted if you read off from the graph. It's just below there, so it would be 17. Okay, next one. A car is traveling at 80 kilometers per hour. How many meters does it travel in 1 second? Which means you've got to convert 80 kilometers per hour to meters per second. Natasha?
$22.2 meters.
22.2 meters per second. Okay, that's 22.2 and 2 is recurring, if I'm correct. All right, next one, if m is 10, find k. Lester?
36 kilometers per hour.
36 kilometers per hour. Okay, so k will be 36 when m is 10. Okay, I'll just show that on the graph. When m is 10, okay, this is 35, it's around 36. Okay, it's not exactly 35. Next question, letter D. A car is traveling at a speed of 20 meters per second. By how much is the car exceeding the speed limit of 60 kilometers per hour? Garanamo.
12 kilometers per hour.
12 kilometers per hour is correct. Because 20 meters per second is the same as 72 kilometers per hour. If you change that to kilometers per hour, subtract 60 from 72 and you get 12 kilometers per hour. Okay, next question. Question 2. The length of a spring with mesh attached to its lower end can be represented by the equation y equals to x plus 15, where y represents the length in centimeters and x represents the mass in kilograms. The graph is shown below. You are shown also a point 1239. You have to answer the questions that follow. Okay, on your worksheet, you will have to answer the questions that follow. You've got them on your worksheet. They're not on the screen. Just answer them first and then we'll go through those. Okay, we'll just look at the first two questions on that graph. First one is, what is the length of the spring before any mesh is attached? Taumaku. What is the length of the spring before any mesh was attached to the spring?
15 centimeters.
15 centimeters. Okay, the next one, find the length of the spring when a mesh of 5 kilograms is attached. Chutaili?
Centimeters.
10. Is it 10 centimeters?
25 centimeters.
25 centimeters. Okay, it's 2 times 5, which is 10, plus 15 will give 25. The question is, how much did the spring extend when this mesh was attached? Velma, how much did the spring extend when a mesh of 5 kilograms was attached?
10 centimeters.
10 centimeters? You all agree that it's 10 centimeters? Okay, because 15 is the original length of the spring. It extended 10 centimeters. Okay, for homework, you are going to complete question 2. You are going to draw the graph for question 3. And you are also going to answer question 5. 5 on your worksheet. But it's 4 on the screen. All right, the keyword to the pilot teacher is linear. Please stand. Good afternoon, class.
This is boy.
Thank you.